Hi, in this video, I'm going to talk about the difference between marginal distribution versus conditional distribution. So you can see we have a two-way table here, a frequency table. And the first thing you want to do is examine what are your rows and what are your columns. So if you look at the rows, we have boys and girls. So we can actually call this the gender variable here. So over here. And then we have on our columns red, blue, green, red, blue, and green. So we can call that our color preference. Now, if we want to know the marginal distribution, then basically, as the word states, it's the margin of your table, which are your totals. So my marginal distribution are the margins where the totals are. Now, you need to be careful because not all tables have the totals. So if they do not have a total, you need to draw it in or write it in. Okay, so if you notice as well, what I have are counts here. So there are red, blue, green, and the counts are labeled below. And now it's asking, find the marginal distribution for the gender variable. Well, if we want to find the marginal distribution for gender, I'm going to look at the rows. So basically, anything to do with marginal distribution is what I highlighted in yellow. So if I want to find the marginal distribution for gender, first I'm going to write down boys, which is only what I highlighted in yellow. So it only consists the totals. So it'd be the total boys over our total sample size. This over here is our total sample. So we would go ahead and say that would be 14 out of the total sample, which is 27. And if you calculate that on a calculator, that comes out to 0.5185. Now, you do want to always leave 4 decimal places, but at least 3. So once this is in decimal, of course, you convert this to percentage. This would be the same as 51.85%. Okay, but we are not done because we haven't finished with the gender. We still have the girls. So if I want the marginal distribution for girls, I'm going to look at the total girls. So I'm going to look across, and that is 13 over the total sample size, which is 27. So when you're looking at this, 14 and 13 should up to 100%. So 13 out of 27 in your calculator, that would give you about 0.4815, which is 48.15%. And again, notice that these two add up to 100%. All right, next it's asking us to find the marginal distribution for color preference. Well, where is color preference? It is the title of our column. So if you look down, we have red, we have blue, and we have green. So the color preference are the columns and the gender are the rows. So if we want to do the color preference, again, we're going to do the same thing. I'm only going to look at my highlighted regions, which are my total. So anytime you want marginal distribution, you only use totals for your numbers. So you can go ahead and write red, blue, and green, and the order in which you write it doesn't matter, but this is organized since our table listed in this order. So if I want the marginal distribution for the color red, I'm going to look at the total red, which is 7 out of 27. So 7 out of 27, and that is about 0.2593, which is 25.93%. I'm going to go ahead and do that for blue. That would give us 9 out of 27, which is about 0.3333 or 33.33%. And now I will do the same for green. That would be 11 out of the total, so 11 out of 27. And that gives us about 0.4074, which is 40.74%. So basically, this is it for the marginal distribution for gender and the marginal distribution for color preference. In the next video, I'm going to discuss conditional distribution.